Nice to meet everyone. Thank you for coming. So I'm Bharat. I work at the EF, and today I'll have my talk on. The title of my talk is ePBS for block builders, and the idea is like I want to cover this huge protocol change and what it means ideally for like people building the blocks on Ethereum, and like what I think is relevant over there. So this is the goal of the talk. As Adrian mentioned, we'll cover a little bit of the history of PBS, but primarily the goal is to cover ePBS from a technical point of view, and to primarily cover aspects of ePBS which I think are like relevant for builders. And yeah, so that's what we're going to try to do. ePBS is a huge change. It's a massive. It's quite a complex change, and I'm gonna try to like cover most of them and see like see how we can go through that. And yeah, so this is the agenda. We're just gonna briefly go over what is ePBS, what are the main motivations for ePBS, a high-level overview. This is gonna be one slide, and we're gonna try covering like individual components of ePBS and see, like try to understand them, try to see what are the intricacies involved in them. So first up, PBS. This image is probably a very pessimistic view on PBS, but like PBS is a design paradigm fundamentally in my view. It's where less sophisticated proposers delegate block building to highly sophisticated entities called builders. Block building is fundamentally building efficient blocks, at least is a very is a sophisticated activity. So you have these like highly sophisticated entities, builders who who do this, and PBS arose out of like a necessity to avoid a centralization in the validator set, because there are clear incentives to extract MEV, and MEV is fundamentally like centralizing. So it arose out of the necessity to kind of to have more decentralized validator set. So, and the more important part of PBS is it introduced trusted relays into the Ethereum chain. And fundamentally what relays do is they enable like a safe exchange of payloads between like a proposer and a builder. And they also like ensure that the builder pays the proposer if their bid gets selected. So that's fundamentally like PBS. That's on a high level what PBS is, why it came about, and how it looks like today. And so why do we need ePBS? ePBS, or enshrined proposer-builder separation, right? Just by its name, it technically like enshrines PBS into the protocol. So why do we need it? So there are two main reasons. One, the primary reason in my view is it enables Ethereum to scale more. So we want to like scale the TPS, we want to increase the TPS. And how do you do that? You scale the gas limit and you scale the blob count. And you also want to do that while maintaining a decentralized network. The biggest bottleneck is the 4-second attestation deadline. So a proposer needs to broadcast the block, and at the same time, attesters need to execute the payload and check for data column availability by the 4-second deadline. The problem is that as you increase the gas limit and the blob count, the block gets bigger, making broadcast harder. Not harder, but like you increase the bandwidth requirements, and of course also you take a while to execute the block. So doing all that in a 4-second attestation deadline can get like tricky. And of course, the second reason is to remove like the trusted relays. And as like the gas limit and blob count goes up, self-building full blocks will get more difficult. Filling up the blocks is going to get more difficult. It's going to get fundamentally like it's not going to be in the reach of all validators. So there is a certain requirement to delegate block building to external builders. But the problem is, to this pipeline, there is the trust aspect. You have like 7 relays which do like 7, I don't know if I got the number right, but like got a very limited number of relays through which all the blocks flow. And ideally, it's not a great idea to have trusted entities in the decentralized system that we're trying to build. So these are like, in my opinion, the main motivations behind why we have we had PBS, and how this led to like to demand for like enshrining that entire pipeline into the protocol, right? So at this point, like I'll just give a high-level overview. This is like a 4 bullet point like thing on ePBS. It's just EIP 7732. It's a headliner for Glamstam. the upcoming hard fork. And the 4 main points is that ePBS like separates the execution payload from the beacon block. You kind of are able to pipeline processing of the payload and the beacon block in separate timelines. And then the other part is like you enshrine builders into the protocol. What does that mean? We'll come into that. And builders can send bits over like the P2P network along with serving bits via the builder API. And of course, it introduces like a trustless payment mechanism where builders pay to the proposers via their stake collateral. So this is like on a very high level view. We're going to now dive into like each thing. So how do you become an enshrined builder in ePBS? So builders are like new entities introduced in the beacon state, like along with validators. So you can see on the screen, this is like a beacon. This is like a field in the beacon state, which is like builders. It's basically a list of, basically it's an SSZ list of builders with some limit, and this sits alongside with validators. And if you want to create a builder, you need to stake at least 1 ETH with the validator deposit contract. And the only thing that differentiates a builder from a proposer is a 0x03 withdraw credential, right? So builders, like all builders, have reserved like the 0x03 withdraw credentials. And what do you do with the collateral that you stake? The collateral that is staked is basically used to pay the proposers. Like if the trustless payment way is chosen, it's used to pay the proposer if the bid is chosen, right? And on a side note, like there's a new EIP 8282 that might change this flow. Basically, they're introducing a new builder deposit contract, but I'm not going to get into that because that's quite still in the works. So this is basically how you become a builder. Stake with the validator deposit contract and with the 0x03 withdraw credential. This is on a high level, a diagram which I think consolidates the flow. You send a deposit message to the validator deposit contract. The EL like reads the contract, and I mean reads the contract is a very like high level way of putting it. But then the EL like propagates these deposit messages to the CL via execution requests, and the CL immediately writes it to the beacon state. And I think the immediately writes it to the beacon state is kind of an important point, because validators are queued in the CL. When the CL like reads a deposit message for a validator, it's queued and processed like I forgot the sweep rate, but process it every block. But builders aren't. Builders are added to the beacon state immediately, like when the deposit message is seen. This is how a builder looks like in the CL. This is what the CL sees, right? So just if I can briefly walk through what a builder is to the consensus layer, you have the builder pub key. Version is just for versioning the object. You have the execution address, which is basically the withdraw credential. When you withdraw your stake collateral, it goes to that execution address. The balance, which is the stake collateral. You have the deposit epoch, which which is basically the epoch at which the deposit message was seen. And a builder is basically active only when this epoch becomes finalized, right? Only bits from active builders are considered. And and you can withdraw from your stake collateral with a voluntary exit message, and the collateral is withdrawable after 8192 epochs. That's the time you need to wait, and after that it gets added to the withdrawals queue. And then you can also like top up your stake collateral. That is, let's say if you want to add more, you want to stake more and bid higher, you can always add it up, and it's added immediately. So that's how a builder looks like in the protocol with ePBS. Now we'll just briefly talk about what are the changes in the beacon block. So as I mentioned in the high-level overview, like you separate the beacon block and the payload. So if you look at the beacon block, you can see that the execution payload is removed from the block, and we've kind of replaced it with a signed execution payload bid, right? And we'll get to what that means. And you also have the payload attestations, which we'll get to, and the parent execution request. And I think we leave the parent execution request as a little out of the scope for this talk. It gets to like deferred payload processing, which I'm not going to cover today. So what's a bid, right? What's an execution payload bid? The signed execution payload bid is just a signed version of this. So the bid is basically the object that the builder shows to the proposer. Hey, like I want you to include my block in my bid. I want you to like include my block. So this is my bid, and The bid basically contains like the parent block hash, the parent block root, on top of which the on top of which the builder is building on, the block hash of the execution block of the builder, the RANDAO, the fee recipient. Fee recipient is used to like pay the proposer. Is the address of the proposer to whom the payment for the bid goes. Then you have the builder index, you have the gas limit of the bid. I think these are like fairly, these are like self-explanatory. The key parts are the value and the execution payment field. The value field indicates the trustless payment amount. So how much are you going to pay from your stake collateral? And the execution payment, which I think is not like well named at this point, is basically like the off-chain like payment, right? Let's say the execution payment is 1 ETH. The protocol doesn't like settle this payment. The protocol assumes that this payment is settled by between the builder and the proposer like off-chain technically. There's no validation in the protocol whether this payment goes through. Okay, so yeah, now we have the bid. Now where's the payload? So we have this entity, we have this object called an execution payload envelope, which includes the payload and the execution requests. And the idea is like, this is something the builder broadcasts if their bid gets included in a block, right? So like when the validator selects the bid, the builder ideally like broadcasts this payload to the PTC committee. And like, we'll get to what the PTC is. The PTC basically votes for the availability of the payload and the blob data associated with it. And builders can have different reveal strategies on when they should broadcast. We'll get to that like a bit later. But the idea is like a builder fundamentally, when the bid gets selected, they want to reveal this payload. So we've just spoken a ton about the PTC, the Payload Timeliness Committee. So what is that? Every slot, you have a committee of 512 members who attest to the timeliness of the payload and the availability of the data columns for that block, right? So based on this, they send so-called payload attestation messages, and you're gonna have a different PTC committee almost like every slot. Not almost, you have a different PTC committee. Every slot, they're selected from the beacon committees, they're sampled from beacon committees. So this is a payload attestation that the PTC sends. So this is submitted at or before the PTC deadline based on if the payload and the blob data has been seen by the PTC members. The key aspect is that the PTC doesn't execute the payload. I think that's probably the most important thing. They don't execute. They just determine if the payload is available. And that's what the Boolean fields in the object represent. Basically, they basically say, okay, like, I've seen the payload, I have the blob data is available, I'm good for that beacon block route and for that slot. So what's the point of this, right? So the proposers use this. In fact, it can be used, I'll rather say proposers can use this to determine whether to extend on the payload of the previous block or not, right? So we'll get to what that means, but they can use it whether, they could use this to reorg the payload of the builder. And I think that's why this is important for builders to know. And there's a quorum, which is like greater than 256 attestations. If I see more than 256 attestations indicating that the payload and blob is available, I consider the payload to be available, the envelope to have been like broadcasted widely to the network. So I just spoke about the PTC deadline here. What are the changes in the slot structure in Ethereum? So this is like before ePBS. You just have like t equals 0 is the block proposal, time t equals 4 is the attestation deadline, t equals 8 is the aggregate deadline, and you're good. I didn't include the sync committee deadline, but like that's fine. After ePBS, you kind of add the PTC deadline, which is like a t equals 9 seconds. The attestation deadline changes. We see here it's represented at t equals 3 seconds. This is based off like the latest spec, but I will say that this is something that can change. This is not permanent. This can be changed. People have been speaking about 2-second attestation deadlines. We will get to that. But that's something that's still up for like debate on how much should we reduce this by. So that was a lot. Till now, like this is like there's a lot in the CIP in general. I just wanted to like kind of summarize everything we've seen. Like this is hope people can see stuff here. But as a summary till now, you have the current slot proposer. The proposer like fetches the P2P bid, fetches an execution payload bid from a builder, either via the P2P or via the builder API, puts that bid in their block. Let's say they like it, they put the bid in their block. They broadcast the block to the beacon committees for attestations. And then when the builder, the winning builder, receives the block. They broadcast the payload envelope to the PTC. PTC sends attestations which influence the next slot proposer on whether they should extend the payload or not. And we will get to what payload extension means in a bit. So before we get to that, one thing I want to cover is what are like proposer preferences. So we've spoken about like the bid having the fee recipient and the gas limit. Now, builders can also submit bids permissionlessly. So you need to have some way of the proposers like to indicate their preferences. So the way the protocol does it is we have this notion of proposer preferences. This is an object that's gossiped on the proposer preferences gossip topic on the P2P network. And it's sent at epoch boundaries. So let's say I'm a proposer. I'm going to propose in the upcoming epoch. I will send it at the epoch boundary, basically. And it's very self-explanatory, the fields. You have the target gas limit, and you have the fee recipient of the validator associated with that index, the proposal slot of the validator, and you have the dependent route, which I'll not get into. It's probably a more niche thing. It's for understanding which proposer look-ahead is used in periods of non-finality. Probably like, I would say it's out of scope for now. And I think the key thing is bits are validated on whether they satisfy the expected preferences. And one point I didn't note here that I should have noted is that the validation doesn't happen in the state transition function. The validation happens in the gossip. So let's say you send the bid, and one of the proposers and one of the validators in the hop sees that, hey, the fee recipient doesn't match, the bid is dropped. It's not propagated on the P2P. Probably not a big issue when you're talking about the builder API, but yeah, something to note. This is a simple thing. How can you bid on the network? Join the network, like do all the peer discovery, and you can just bid on the execution payload bid gossip topic, just broadcast your bid on that topic. There are some caveats here. One thing is to prevent DOS. Only one bid can be sent per builder on the P2P for a given slot. It's not ideal, but that's the current spec right now. There is also, on the P2P, you can only pay the proposer via a trustless payment. So we've seen that there's a bid.value and the bid.execution payment. On the P2P, you can only pay via the trustless payment because the builders are anonymous, you generally can't trust them. And also, when you send on the P2P network, proposers only consider bids for the current slot or for the next slot. So that's a smaller caveat. These are like some caveats on the P2P network when you bid on the P2P network. So this is an interesting thing, I think, for builders. There's something new that ePBS comes, that is the notion of payload reaux. This is a wordy slide. I'm just going to get to some diagrams. So pre-ePBS, so when a proposer wants to select their head block, how do you do that? You start from the justified checkpoint, and you walk the tree with LMD ghost. You can ignore the attestation weights, they're just for representation. But you walk the chain, and you reach like, okay, the heaviest chain, and you go to the leaf, which is B4. Now you have the beacon block route of B4, and with that pre-ePBS, you know the parent block route on top which you have to build, and along the same time you know the parent block hash because both of them are in the same object, right? The payload and the block are the same. Post ePBS, this changes. Fork choice changes a bit. So what changes now? So you start from the justified checkpoint as usual. You walk the chain, right? Now you reach the leaf, which is B4. Great. But now the question is, do you build on the payload of B4 or not, right? I think I've probably like messed up the parent block hash things, but so you have two options. You have the option of building on B4 empty and on B4 full. And what does that mean? When I build on B4, so I use my parent block route as B4, but when I build on B4 empty, the parent block hash thing is wrong, but like when you build on B4 empty, you build on the parent block hash of B2, or the block hash of B2, right? And when you build on B4 full, you build on the parent block hash of B4. It's actually, the parent block hash like arrows should be like one, should be like corrected there. So you can decide whether you want to extend that payload or not, and that's basically what it means. If I extend, I build on B4 full. If I don't extend, I build on B4 empty. So the idea is like for the same beacon block route, you can build on different parent block hashes. And how does the proposer select whether I should use B for empty or B for full? There are two ways. It's primarily based on the PTC's vote. They look at the PTC's vote and say, okay, the PTC voted that the most of the network has the payload available. I am going to build on full. Otherwise, I build on empty. So that gets to this. So the fork charge decisions include knowing whether you want to extend the payload of the beacon block or not. So the idea is like the payload can be reorged, but the beacon chain can still continue. I think this is probably something new with ePBS that I think builders need to, I think it's interesting for builders. And the most common situation for a payload reorg is similar to a beacon block. It's again when the payload is not available to the majority of the network. It could also be reorged if the PTC hasn't seen the payload. But that's kind of unlikely. If your payload is available to the majority of the network, the PTC will see it. But your payload getting reorged is like a real thing that can happen. And that draws to like when should the builder reveal the payload? This is probably a wider discussion, but ideal behavior is to reveal it immediately. Like when you see the block with your bid, you just reveal it. But that's also like not ideal. Like, I mean, sorry, that might not be good. Like, because you could have a situation where like that beacon block doesn't become canonical. And at that point, you know, like your payload's not gonna become canonical too. So a builder could listen to attestations for the block. You could listen to, okay, like, you could listen for attestations and check whether this block could likely become head, and based on that, reveal the payload. Now, how many attestations do you listen to and stuff is something like we can discuss, and it's up to builders how you choose to implement it. And the payload exactly should be revealed widely to the network to avoid a payload reorg. This is a case which is very unlikely to happen, but a same slot unbundling could happen if the block is not widely disseminated. And what I mean here is, let's say the beacon block is not widely disseminated, but the payload is. A proposer could see the payload, build a new block, send it to disseminate that block, and the proposer will get slashed, but if the second block gets more votes, then that still becomes canonical. And maybe 16th of losing 16th of slashing or getting slashed is not too bad compared to the value of the payload. So this is basically that. The last thing is like trustless payments I want to cover and trustless payments, like how do they work? So we have the bid.value field in the execution payload bid. They indicate like, okay, like this is the amount the builder wants to pay from the stake collateral to the proposer. And this basically completely leverages the withdrawal queue in Ethereum. So what happens is, let's say we have a block with the builder's bid, and there's a trustless payment. This builder pending payment object gets recorded which has a weight and the withdrawal, right? And the withdrawal is basically the proposer's like address with the amount to pay and the builder from whom the payment should go to. And if the payload is revealed, there are two cases: if the payload is revealed or if it's not revealed. If the payload is revealed, the withdrawal is added to the withdrawal queue. You just add it to the withdrawal queue. The withdrawal queue sweep like sends it to the proposer. If the payload is not revealed, there's a condition. If the block gets enough attestations, the withdrawal is still added to the withdrawal queue. But this is something that's settled like every 2 epochs, right? So every 2 epoch, at an epoch transition, you look at all the pending builder payments, like, hey, has this been settled? This has not been settled. Okay, has this got enough attestation weight? If it gets enough attestation weight, you create a withdrawal and just like pay the validator. Yeah, so the last topic I want to cover today is like the builder API. How does that change with ePBS? The one thing is like the builder API, at least like the way I see it, is post ePBS is just a faster way to get a bid. In contrast with pre-ePBS, it facilitated like the safe exchange of payloads, but that's not a problem anymore with ePBS. On the builder API, builders can use the execution payment field. Basically, they can pay via the execution layer as the last transaction, like how they do today, right? Via the last transaction of the payload. And fundamentally, the proposer calls the get execution payload bid endpoint to fetch a bid from the given builder, and that bid is the execution payload bid we just covered. And the proposer calls the subbid signed beacon block endpoint to send the beacon block to the builder if their bid has been included, and after that, the builder is just responsible for revealing the payload. The proposer has nothing to do after this, right? And this is basically a sequence diagram. It's very simple, fundamentally. You just call the get execution payload bid with the slot, the parent root at the parent block hash, and the validator pub key, get back the best bid, and send the beacon block with the bid. There's like the builder preferences. I'll get to that in a bit. One thing is like proposers can like sign the request to fetch the bid. This is completely optional, and builders can use this to identify whether this request comes from the proposer or not. And the idea is like, what do you sign over? This is completely arbitrary. We enforce it to be the builder's URL right now, but the spec has just like a 4096 sized SSD list, which probably can change in the future. And the last thing I want to cover is the builder preferences. You have this notion of the max execution payment. It's ideally used to constrain the execution payment a builder can offer based on whether the proposer trusts the builder or not. Because the problem is like you have no like the payment via the EL layer completely happens via trust, and which like sure, if I trust the builder, that's fine, but if I connect to a builder who I don't trust, which may happen, you could use this to constrain the payment. Because the builder API is still a desirable way to get a bid. It's a faster way to get a bid. So this is more a lever for the proposer to kind of like calibrate their trust based on like the builder. This is something that is submitted like every epoch by the proposers who will propose in the upcoming epoch. Let's say I'm proposing an epoch E+1. I'll send that at epoch E, right? So this is sent to the builders. Yeah, and that's it. It's a huge EIP. I couldn't cover a bunch of things still, but it's a huge EIP. There are a lot of changes. It's hard to fit in the time that we have, but that's it. And any questions, like happy to answer, happy to take it after the session. So yeah, thank you guys.
Do you actually think that the B2B layer will be used for adoption, or is it mostly like a backup? It's a backup.
I think it's a backup. Like that's because if you look at one of the caveats there that you can only send like one bid, this thing like per builder, I think it's a backup. Like you need a permissionless way to sell the bid, but I don't think it'll be used as much. Yeah, the question asked is that whether the P2P layer will be used for sending bids.
Builder that's only submitting trusted bits, so setting value to 0 and execution payment to non-zero. Do you still have to stake collateral on the consensus layer?
Yeah, you do. So the question is like, let's say I'm a trusted builder by the builder API. Do I still need to stake collateral on the to become a stake builder? Yeah, you do. So the minimum stake is, as I mentioned, 1 ETH. So let's say you are a trusted builder, you're paying completely via execution payments. You can just take 1 ETH and pay and do your payments via execution payment. And should make sure that the collateral doesn't go below 1 ETH.